Hey folks, Mr. Dell here. We are looking at a problem that I have to graph a couple equations and then find their point of intersection and label it. So this is a problem from CPM's course 3, and this is section 6.1.2, number 6-14. It says graph each equation below on the same set of axes and label the point of intersection with its coordinates. So that's actually what they're asking me to do, is solve the system of equations, right? If I wanted to rewrite these directions, just so we can have some connection here of that, solve the system of equations, right? Finding the intersection point is the coordinate, the ordered pair, the xy, that makes both equations true. So let's go through the process. First of all, graphing. We notice these two equations are in a certain form that allows us to graph nice and easy. And that's y equals mx plus b, where the coefficient of x, that m, the number in front of the x, the coefficient, is the growth or the slope, right, of the line. And then the b, the constant, the number at the end there, that constant is the y-intercept. It's the initial value. So if I'm going to graph this one here, I always start with the y-intercept because I know this is my y-axis. This is my x-axis, right? The y-axis, x-axis. So the y-intercept is at positive 3. So on my y-axis, there's where positive 3 is. 1, 2, 3. So that is a point, 0, 3, right? It's actually 0, 3. That point, 0, 3, is a point on that line. It's a solution to this equation. So if I put 0 into x, I get 3 for y. That's why we start with that y-intercept. Now, I use the slope or the growth to find my next point. What do I know? I know that every time I go over 1x, I know I'm going to go up 2. My growth is 2, so I go up 2 over 1. I go up 2 over 1, right? The slope is your growth of 2 every 1 over. And so I only got a couple points this way, so to keep that same linear pattern and have a good graph, I'm going to go down 2 over 1 as well, kind of keeping that same pattern, because it's from point to point is up 2 over 1 in the positive direction. So when I'm done, my graph, my line here, because this represents all the solutions, that line, that solid line, represents all the solutions to that equation. Every single little dot represents an ordered pair, an x, y, that would work in this equation. Okay, so there's that first one. So then the second one, this equation, so again, I'm going to use my y equals mx plus b. So b is positive 1. So in this case, here at 0, 1, at that point, that's the y-intercept. And then from there, I look to see what's the number in front of the x. Well, we don't see 1, but remember, there's always a coefficient of 1. When we don't have a number in front of a variable, there's always a 1. So this time, its growth is 1 over 1. Every time I go up 1, I go over 1, right? 1 over 1, solid 1. And then, again, I have this growth this direction, so I can go the other way, so that way I can see where what the pattern is for that equation, for that line. And I have this solid line represents all the solutions, right? And I usually label all the solutions to y is equal to x plus 1. So that solid line are all the solutions to y equals x plus 1. This line is all the solutions to y is equal to 2x plus 3. So if I wanted to find the common solution, that would be the point of intersection. The common solution. I'm going to write it down so you can hear me and see it. Common solution is the point of intersection, right there where those two lines intersect. So Where's that at? On the on the x-axis, it's at -2. On the y-axis, it's at -1. So that solution right there, that common solution, would be labeled -2, -1. So, and I'll put it out here so we can see it clearer, and I'll circle that. So -2, -1, where x is -2, y is -1, that point right there is the intersection, and it's the common solution. Okay, there we go.